The following is a re-recording of a talk I gave at QA or the Highway Conference in 2024 in Columbus, Ohio. I had a great time there, but I don't have a recording, so I'm going to try it again. Let's get started. My talk is called Pair Testing and Other Radical Ideas. I want to talk about some practices that were once considered extreme, but are now more mainstream. I'm going to review the Agile Manifesto and extreme programming and some other concepts that maybe were radical 20 plus years ago and see how they've stacked up to the hype, where they've gone off the rails, and what we can learn by taking a closer look at how they were originally adopted and what they've become. Don't worry, this isn't going to be a flame war about how agile is the one true process or agile is dead or anything like that. It's meant more of a tour of past perspectives, mine specifically, and things we might learn from comparing how things were done then with how we do them today. And I'll talk more about pair testing specifically, how I've done it, how you can do it too, why you might or might not want to adopt pair testing or revisit any of these old ideas yourself. And I hope we can have a little fun doing it. I've accompanied each slide with a pop cultural reference from the past, usually music or movies, and a short musical clip if the audio works. You can play a guessing game if you want to see if you recognize the reference and can tell how it relates to the topic. Though I admit that sometimes it's a very tenuous relationship that may only exist in my mind. All right, about me, my name's Aaron Evans, and I'm a tester. It's been 25 years since I wrote my first defect. Bug. We called them bugs back then. I have a QA strategy consulting business, and I'm a test architect at the Massachusetts Medical Society, publisher of the New England Journal of Medicine. I live in Montana, in the woods. I work in a yurt. It's a big round tent-like building. This is my office. It's nice, except it can get hot in the summer and cold in the winter. Back in my day, things have a way of losing perspective, right? I don't know when it was I became a senior tester. That's senior as in senior discount, not like senior prom. I never went to mine. Maybe it's the gray hair in my beard or the dad bod or the chip on my shoulder because no one gets my jokes anymore. It's not that I think I'm smarter or faster. I'm definitely getting slower or better than anyone else. But having been around the block a few times, I've gained some experience. Whether I've learned any wisdom from that experience is another matter. So, I'm going to subject you to some nostalgia of mine, and you're going to have to deal with it or pull me off the stage. You can't do that here because I'm back home, or just sit back and enjoy the show. And get off my lawn, uphill both ways in 6 feet of snow, and we liked it that way. All right, things have a way of coming back around again. What's old is new. I've seen trends come and go, good ideas discarded, bad ideas resurrected. And, like the philosopher Daniel LaRusso once said, what goes around comes around. Let's talk about the Agile Manifesto. Back in 2001, a group of people got together at a ski resort in Utah, not to ski, but to start a revolution. Just kidding. The outcome of that 3-day meeting was the Agile Manifesto. They had some common beliefs, but also diverged on what to do and how to do it. The attendees didn't expect much to come out of their talks, but, to quote, they were pleasantly surprised with the result. Those core beliefs were put forward with the common theme of reducing complexity in software development and being better able to respond to change, to be more agile or agile. Let's bring this up. The Agile Manifesto bluntly states, individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. That is, while there is value on the items on the right, we value the items on the left more. This is what Agile has become today. This is the SAFe framework, or rather, this is a small segment of the SAFe framework. It's the overview. It is a complex array of processes designed mostly around management and governance. Let's talk about Agile and the word agility. It wasn't really in common usage before the Agile Manifesto, certainly not in software development. It was used, I think of, as a stat in role-playing games, important when you play a rogue or a thief. Or agility was a more general term for athletes to go along with speed and strength. If you'd have talked about an agile coach 20 plus years ago, people would have thought you meant someone who stresses flexibility and nimbleness to athletes. Often, what we call agile today is anything but nimble, flexible, adaptable, or lightweight. Nowadays, everyone talks about being agile, and it's accepted that everyone does agile, whatever that means. But what has it really become? There's one thing that I like in this graph is someone pointed out, I can't attribute it, but the question was, looking at the SAFe framework, where does the work get done? Now you see this little loop right here. I guess you can't see it, but there's full bullet points in the lower right quadrant, and one of those is execute. Someone else responded to this post and pointed out that that's been fixed. In the latest version of the SAFe framework, 6.0, they have removed those bullet points, including execute. All right, let's talk about extreme programming. Where did Agile come from? There were several processes gaining some popularity in the 1990s, and one of them was extreme programming. Kent Beck wrote a book called Extreme Programming Explained back in 1999. It came out the same year as The Matrix. It was the 1990s. Everything was extreme. Extreme sports, alternative music. I think the name was somewhat tongue-in-cheek, but the idea was we have these principles that we know are good. Let's turn it up to 11 and take it to the extreme. Writing tests is a good thing, so let's write our tests first. Releasing software is better. Let's release it all the time. Collaboration is good. Let's program together. Pair programming, test-driven development, and continuous integration are key components of extreme programming. Two driving values here are making things simpler and making change easier, with the goal of reducing risk and increasing opportunity for change. No waiting months or years or risking a project getting canceled. Working on delivering value and get feedback rapidly. So there's a triangle of values, right? Time, money, and quality. Often the expression is pick two. There's a way to look at this that how can you decide? Often time never budges, money never budges, so quality has to be sacrificed. As a tester, I don't love that equation. There's another leg on this triangle, we'll call it, and that is scope. And this is one thing that has been discussed. Rather than sacrificing quality or increasing time or budget, you can reduce scope and deliver later. You can only do that, though, if you're willing to do things in short iterations. Now, some of these ideas that go along with extreme programming are just that, extreme. But there are also some good common sense ideas too. And you don't have to take it to the max. Maybe 90% volume is enough. I'm going to talk about pair programming and testing in more detail, but let's revisit some of the other agile ideas from the turn of the millennium. Let's talk about Scrum. The less that's said about Scrum, the better, actually. I have in parentheses here, proceed to deliver epic rant. And I asked the attendees at QA or the Highway, and they told me to go ahead and do my rant. So here it is. The term Scrum comes from the game of rugby. It describes a resetting of the ball when it becomes unplayable after an infraction, such as a forward pass or out of bounds, which results in a ruck where all the players link arms together, and in the scrum, they try to pass the ball into the middle of that ruck towards their own players. It's similar to a down in football for us Americans, but slightly different in that a scrum is just bringing the ball back into play after it has stopped. Scrum is famous for its stand-up meetings where everyone stands in a circle or a huddle and talks about what they've done, what they're going to do, and if they have any blocking issues. Often that has become a case of, I've worked on item 1, 2, 3, and I've completed it, and tomorrow I will work on item 4, 5, 6, no issues. No one knows what item 1, 2, 3, or 4, 5, 6 are. It's right there on the JIRA board or Rally, but it's never up long enough for anyone to see what's happening. So nobody knows what anyone else is doing, and no one is communicating. Let's talk about stand-up meetings. The point of a stand-up meeting is what? To stand up. Now, with remote work being so common nowadays, or with technological tools allowing people to sit in front of their computers, they don't stand up in a Scrum meeting. You're often sitting down, which means you're comfortable and you can keep sitting and you can keep talking and meeting instead of getting work done. The idea of stand-ups are you get uncomfortable standing, you want to end the meeting as quickly as possible. Now, Scrum, the word, was first used to describe business processes in the Harvard Business Review, of all places, by a pair of Japanese professors talking about product design. It was adapted in the 1990s by Americans, including Kent Schwaber and Jeff Sutherland, both signers of the Agile Manifesto, and applied to software development practices. I don't pretend to know too much about rugby, but based on how it has been used in software development and project management, I think it's safe to say that they don't either. There are some useful things to learn from the process, however. The idea of short iterations or resetting the ball when it becomes unplayable, and that you should only commit to as much work as you think you can do in that short time frame, emphasizing daily face-to-face communication, even if it's over camera, kept brief by forcing you to stand up throughout the whole meeting. The outdated idea that teams should be cross-functional, I think we should go back to that. And the concept that periodic rituals and pauses with commonly understood names like kickoff and retrospective, again, football, not Scrum reference, which encourage frequent team alignment, planning, and reflection. However, the analogies are more apt to American football, or are they? I think we're better served by talking about huddles and downs and so forth, rather than rugby, which is a game with literally no rules. And tactics, which are more about wearing the opposing team down with brute force than any cohesive strategy. And there's also the fact that a scrummage, that's that scrum where people are interlocking their arms, almost always results in no change in the status quo. The team with the ball, over 90% of the time, gets the ball back. But how about Scrum nowadays? Does anybody like Scrum? What it has become? A status meeting where no one understands what your status is, where all the information is already in some software tool that's hard to navigate, where a non-manager asks you to report on your progress. The idea that people who understand neither the product nor the software should be in charge, and whose management training consists only of a weekend course and payment for a certificate of completion, is beyond ridiculous. Let's talk about test-driven development. While agile brands, including Extreme's programming and Scrum, got started before the turn of the century, it didn't really gain momentum until, in my recollection, around 2004, 20 years ago. Test-driven development was probably the most visible of the Extreme programming practices. The idea was that you write tests first, you write tests for everything, and tests describe the requirements and document the architecture. So tests drive development. I think that's a great idea, and I love writing tests first. I think it leads to cleaner architecture and helps avoid overbuilding. If your tests are correct and they're passing, your system should be working correctly. But there's something a lot of people don't notice. The second D in TDD is development. These are developer tests, unit tests, or integration tests that are designed to test the code, not to test the functionality of the system, not to find bugs or test usability. One of the more extreme ideas put forward by Extreme Programming is that these are the only tests that are needed. I don't buy that for two reasons. One, you can only write tests for what you know. Bugs exist because of what you don't know, not just because of mistakes made by developers forgetting to do something. And number two, developer time is precious. They're good at building software. The assistance that QA can provide not only saves precious developer time, but allows developers to focus on what they do best, creating software, while testers can focus on what they do best, breaking it. Continuous delivery. All right, you've probably heard the phrase red, green, refactor. Write a test, watch it fail, write just enough code to make it pass. Red, green, and then refactor. Make your code more reliable and maintainable and extensible, and probably some other IBLs. You'll probably know your changes work if your tests still pass. Continuous delivery is how we can check this. Continuously. It's in the name. A lot of developers feel like writing tests, never mind writing them first, is a waste of time. And it is if you never run them. But if you run them all the time and your tests are meaningful and reliable, it gives you a tremendous confidence and allows you to increase your momentum, because you'll know almost immediately when they fail and hopefully what caused the problem. If you have tests you can count on, both unit tests that check the code and functional tests that check the business requirements, you can have the confidence to release software faster and the ability to roll back at any point of failure. All right, refactoring. I mentioned refactoring, right? Tests enable refactoring. Refactoring is the process of making code that works, still works after you make a change. If you make a change and your tests still pass, you didn't break it. Getting code to work is one thing. Being able to fix or extend it is another thing. But if your code is already working, nobody wants to pay for you to refactor it until your code is so complex and tangled that you can't change it without breaking something. Martin Fowler wrote the seminal book on refactoring called Refactoring, but the general idea is to follow simple patterns to make it easier to understand, more extensible, and not coincidentally, more easily testable. patterns, right? Let's talk about design patterns. There was a book often called The Gang of Four, called Design Patterns by the Gang of Four, including Eric Gamma, one of the co-authors of Extreme Programming with Kent Beck. Back in the day, design patterns were all the rage. You weren't a real developer with all caps until you'd read the Gang of Four book and implemented an abstract factory observer builder singleton decorator pattern from scratch. But at a more sensible level, design patterns are just repeatable ways of solving similar problems. Refactoring code so that you can have functions with simple inputs and outputs not only makes it easier to understand, it allows you to test easier and at a lower level. This is something that doesn't get enough attention. Refactoring test automation code and applying common design patterns to do so, it's a big reason why test frameworks often end up with unmaintainable or unreliable spaghetti code and end up having to be rewritten from scratch. Let's talk about behavior-driven development. You've probably heard of BDD, right? Given, when, then. Behavior-driven development wasn't supposed to be about writing tests with those three magic words. It was originally intended as a way to communicate with customers, with end users. BDD is supposed to be about people talking to each other, not testers writing automation with those awkwardly given, when, then steps that nobody really reads, and lots of regular expressions. Cucumber is just some glue code that connects plain English sentences describing the requirements with automated test functions. It's a pretty cool and simple idea, but it's really overhead if the only people reading or writing those specifications are the testers themselves. There's another part of BDD in the user story, not just the given, when, then syntax, but this other part, the introduction, is often forgotten because it's not automated. It goes, as some role, I want to do something so that I can achieve some benefit. It not only provides context on what you're doing and why, it gives a reason. If you can't answer this, if you can't justify so that I can do something, then maybe you shouldn't be building the feature. It's meant to provide examples of behaviors in your scenarios, not exhaustive documentation of your requirements or exhaustive testing. Examples that illustrate what those requirements are. If you have BDD tests that read, given I'm on the home page, when I click the login button, and then it completes the order, you're doing it wrong. DevOps. DevOps was a bit of a latecomer, at least the term, but it comes out of the agile ideas of cross-functional teams. Nobody talks about this, that developers and operations teams should be working together, communicating, collaborating, that working code and reliable environments cannot exist in isolation. It works for me is no longer an excuse. You can't have continuous delivery without some form of DevOps. But somehow, DevOps has gotten put into its own silo. It's a little fiefdom where people maintaining the environment don't talk to developers except through ticketing systems. And that is not what it was meant to be. This may come from excesses of the pendulum having swung too far the other way, where developers were given the keys to the kingdom, or the AWS account, and allowed to deploy unscalable, insecure applications in the cloud and rack up those AWS bills even when they didn't expose sensitive data deliberately. I guess all I have to say here is there ought to be a middle ground, and can't we all just get along? Here we go. I was afraid I lost my audio for this one. Lean principles. Get it? Lean back. In 2008, the economy crashed. We may be in for one of those again. That time, it wasn't because of silly sock puppets selling pet food or overhyped companies selling books or groceries online. But once again, people started thinking about how they can save money. Test-driven development and behavior-driven development are supposed to help you build the simplest possible thing that could work. And continuous delivery is meant to get it in the hands of customers as soon as possible. Whether that works or not, I'll leave it up to you to decide. But The Lean Startup was written by Steve Blank and asks the question, should we even build it? Customer development was the idea then. Not only should customers be involved in development, but they should be involved before. Ask them if they would pay for this feature. And if not, don't build it. Build a minimum viable product, MVP as they call it, and get it in front of them before committing to long cycles of development. Somehow, this whole lean idea became build a fancy landing page and some mock-ups and sell vaporware. I don't think that was the original intent. There is a good idea in here though. Code costs money to maintain, and the more code you have, the more complexity you have, and the more potential bugs. Less code, fewer bugs, lower costs. Lean principles came out of Japanese auto manufacturing. The goal was to eliminate waste, wasted time and materials. On an assembly line, a stoppage means people are standing around getting paid while something needs to get fixed. But an even worse idea was it's worth paying the cost, because if a defect is found after the product is created, after an automobile is assembled and shipped across the ocean, and you need a recall, that can result in lawsuits and loss of reputation. It's better to take a quick hit and fix quality rather than to suffer from poor quality later. That was the idea. Other principles that came out of this are Kanban. Take one task at a time. Pull the chain and stop production if you see an issue. Trusting your employees to do the right thing and empowering them to make a difference in quality and efficiency. Pair programming. Pair programming is a principle that we talked about. Two developers working together. It looks like I've lost my notes for this slide. Pair programming. I'm going to have to edit this. And finally, we get to pair programming. Pair programming related to pair testing. The idea of pair programming is that two developers are working together side by side. 4 hands, 1 keyboard. Managers didn't like this idea because it's wasteful, right? Couldn't these people be doing twice as much if they were working alone? Won't they just talk and goof off instead of work while working together? Well, the principle of pair programming, is great. I love it, and it's what I'm going to base the rest of the talk on. And now I'm going to take a break. All right, I'm back. Pair testing. What is it and how can we do it and why? It's like pair programming, but not necessarily the same. 2 or more people working together on a task and communicating in real time. Usually one leads and the other follows, taking turns and collaborating. So who do you pair with in pair testing? Who can do it? Well, compare with other testers. One way to do it is a senior tester pairs with a junior. A newer employee pairs with an older employee. A manual tester can pair with a test automation developer. Testers can pair with developers, with DevOps or SRE, with management, product, customer support, or even with real customers. Why not? So, how can you do pair testing? What do you do when you're pair testing? And how can you do it effectively? Any task that involves communicating is great for collaborating, whether it's in person, sitting side by side, or just looking over someone else's shoulder. It doesn't have to be writing code. It can be exploratory testing. This works well coupled with automation or any two complementary tasks. You can find bugs or troubleshoot issues, research exploratory testing, or do usability testing. You can write and fix test automation together, just like pair programming. You can work on coding, deploying, running tests, and checking results, proofreading code or documentation, refactoring test automation, or refactoring code while running tests, manual or automated. All right, I ran out of steam re-recording and editing my talk about pair testing and other radical ideas. Stay tuned, and I hope to be able to complete the other half, where I'll go more in depth about the benefits of pair testing, how to make it happen, and some concerns you may have as a tester or a manager about pair testing. I will show you how you can use tools designed to help with pair programming and ways to do it simply without any technical dependencies. And I'll discuss some other topics related to pair testing. Until then, goodbye.